Today we'll be talking about how to control crystal structure and preferred orientation in thin film using solution processing methods. This presentation is by 吴昱泓、陈怡静, and 谢祥胜. Our talk will cover 3 parts: film forming technologies, a quick look at 6 common solution-based methods, advantages and disadvantages, comparing the benefits and drawbacks of each technique, key factors, what affect the crystal structure and orientation in thin films. Spin coating. A liquid is deposited on a substrate and spun at high speed to spread it uniformly, ideal for producing thin, even films. Drop casting. A solution is dropped onto a substrate and left to dry. It's simple and cost-effective, but may result in uneven thickness. Deep coating. The substrate is dipped into a solution withdrawn at a controlled rate and dried, useful for coating large or irregular surfaces. Spray pyrolysis. A precursor solution is atomized and sprayed onto a heat substrate, forming film through thermal decomposition, commonly used for metal oxide film. Electrophoretic deposition. Charged particles are driven by an electric field to deposit onto an electron, suitable for nanoparticle coating and complex geometries. Soldier method involve hydrolysis and condensation of metal oxide to form a gel, followed by drying and calcination to create nanoparticles of films.
Disadvantages. 1. Spin coating. Advantages. Produce uniform thin film on fair substrate. Simple, fast, and cost-effective. Easy to control film thickness by adjusting speed and time. Disadvantages. Not suitable for non-fair or large area substrate. Material waste due to centrifugal loss. Limit control over film composition readiness. 2. Drop casting. Advantages. Very simple and human film. Suitable for thin film or slow drying species. Low material loss. Disadvantages. Poor film uniformity. Difficult to control thickness precisely. Long dry time may lead to defect in quaking coffee ring effect. 3. Decoating. Advantages. Good uniformly on large or 3D substrate. Scalable and repeatable. Thickness controlled by visual speed and solution viscosity. Disadvantage. Slow process. Require careful dry to avoid strain or drip. May need multiple air for sufficient thickness. 4. Spray pyrolysis. Advantages. Suitable for large area and curved surface. Can be automated for mass production. No vacuum need. Disadvantages. Failure for depend on spray and heat control. Overspray and material waste require automation of dryer size and subject temperature. By electro advantages, rapid disposition of ceramic nanoparticle field. Unite for coating on complex shape. Boosting net control by voltage and time. Disadvantages require conducive substrate. Limit to suspension with stable charge particle. Post deposition certainly usually need. 6. Social measure. Advantages. Good chemical homogeneity. Suitable for complex oxide compositions. Can combine with spin coating for versatile field formation. Disadvantages. Sensitive to moisture and pH during soil preparation. Cracking may occur during drying or heating. Require high temperature treatment for crystallization.
First, key factor controlling crystal structure and preferred orientation in solution process, thin fields, precursor composition, and stoichiometry, the metal ion ratio in the precursor solution directly affect the phase purity and resulting crystal structure. Use of complexing agents can influence metal coordination and slow down hydrolysis, leading to controlled nucleation. Second, solvent system and solution property polarity, boiling point, and viscosity. The solvent affect field uniformity and driving dynamics. Mixed solvents or additives can tailor the weighting behavior on substrates, which impacts nucleation density. Third, coating parameters. Spin speed, withdrawal rate, or spray rate determine the field thickness and uniformity. Multiple coating cycles allow for layer-by-layer goals, which can enhance wafer orientation by promoting grain enrichment, low recrystallization, post driving and annealing, condition driving temperature, balance solvent evaporation rate, and precursor distribution. Heating rate also matters. Slow ramping and favor orientation due to control, collision, and cross kinetics, substrate type, and surface properties. Substrate, lattice parameter, and surface energies influence the texture, alignment, or template, growth, texture, or crystalline substrate can promote oriented nucleation and suppress random grain growth. 6. Multiple green heat treatment and oxidizing. Note and reducing atmosphere depth oxidation, state of metal ions, stream pressure, and impact defect formation, which in turn affects unicell parameters and orientation preference. Thank you for listening.